here is x double prime perma label. So this is our transform y-axis, so it's a y double prime label here. Okay. So now and we can read the x double prime. Again, right now we rotate per this choice clockwise, go this way. So the normal stress on this point is -2, so that is 2 here. And on the y prime, the coordinate is 12 minus, so that is 12. Okay. And again, those coordinate systems, x prime or x double prime, those are the artificially defined. If we kind of cover this kind of these symbols, actually you can see this orientation is the same as this one. And that is the local information. And again, when we draw the stress element, we say that I take away from here. Actually, this one should be local around this point. Otherwise, we can mess up the drawing. So we'll kind of take away a little bit. Okay. And now for the orientation here is, let me call this theta P1. And this one is called the theta P2. We can do the calculation. This is 2 theta P1. And this is 2 theta P2. So 2 theta P1, we can do the calculation again using the triangle. So let me pick this one. So if this is 90 degrees, so that is a triangle here. Okay, so do the calculations. It's a 90 degrees, and this is our angle 2 theta P1 here. So for this triangle, and this has a length 3, because the center is from here to here 7, from here to here is 7, and from here to here is 10. So that is 10 minus 7 equal to 3 here. And this is 4, because that is given by the coordinate, the y coordinate of x. So that is 4. So from here you can see the tangent to theta P1 per this triangle is 4 over 3. So therefore, similar to this calculation, theta P1 has a magnitude equal to 26.5 degrees. Okay, and this one has a similar calculation like this one. And for this case, you can see this is the magnitude is 26.5 degrees in which direction? Counterclockwise direction. So that is this one equal to 26.5 degrees. And on the other side, 2 theta s, 2 theta P1 plus 2 theta P2. You can read this one, the two angles take summation is 180 degrees. So therefore, theta P1 plus theta P2 equal to 90 degrees, always in magnitude. So therefore, theta P2 in magnitude equal to 90 minus 26.5 degrees equal to 63.5 degrees. So that means this angle is 63.5 degrees, and this one is clockwise. Clockwise. Okay, good? Okay. So now we fix the 3 part, and then for this one will be straightforward. And that one, I need to redraw this one. So, and now I want to demonstrate for this part here. And let me utilize this example. And would that be okay? And let me, okay, let me erase this one. So on the same circle, and let me draw the circle one more time. So this is average 7, and radius equal to 5. And our given x and y. So this is our x, this is our y. So now for this given information, if we want to calculate the maximum shear stress, what is the magnitude of the shear stress on the North Pole and at the South Pole, right? So here, either this point and this point corresponding to the maximum shear stress. So here the magnitude is equal to R. Okay. Minimum simply has a negative value to that one, so we skip that part. So now for those one, we fix the value things. And again, the maximum minimum, they have the same. They are equal in magnitude but opposite to sign. And now we determine theta s. Again, we stick with this one to obtain, to transform into a specific orientation in which the maximum shear stress occurs is we can go either choose these directions. Okay, that's option 1. So here is our 2 theta s. And the other option is we go this way. Let me go. So the first option is go this way. Okay, that is the same, 2 theta s. And let me go to theta s1. So that means under this orientation, in this orientation, this will be transformed x axis, then labeled as x prime. So go this option, and y will go to here, is called the y prime. Okay, so then from here we can calculate 2 theta s1. And earlier we can utilize our information here. Earlier we have been calculated, this is 53 degrees. So from here you can see 2 theta s1 plus 53 degrees equal to 90 degrees. So therefore 2 theta s1 is 1/2 of 90 minus 53 degrees is how much? 37 divided by 2, 18.5 degrees. And so in this orientation we have, this is a given x, y, 10, 4, 4. So this is the clockwise direction. Okay, from here we calculate the theta s1 in clockwise direction. So in clockwise direction we rotate by 18.5 degrees in this way. This will be our transformed x-axis, y-axis. So the x prime, we have a coordinate how much? 7 and 5. And remember, this has our notation. So 5 corresponding is this orientation. So with this one, we can calculate label. So in the x prime direction, we have the normal stress equal to 7. And 7 is positive, so tension here. And now with this 5 is the shear stress. The shear stress in this prime direction has this kind of notation. So the shear stress will be on this plane. Which direction? Point up or point down?
Pointing up.
Point up. This is a very important step. Mapping the information from the Mohr circle to the stress element. Are we okay? And one more time. For y, we can try another exercise. Y has a coordinate is 7. And the tau axis, the tau coordinate is 5. And 5 is in the range like this. Okay, so now we can practice to map. So here the y prime, this coordinate represents is the element, stress element here. So that is 7. Normal stress, positive. And the shear stress is 5. Again, the shear stress is in this direction. Which way?
That way.
This way. Because this way has a tendency to rotate this stress element about the origin in clockwise direction, like this. Okay? And that one pretty much, I think to this step, you should be able to do the most of the problems, but 2 more issues left, and probably coming back on Monday. We have 2 more issues. The other one issue is I'm going to explain to you why we have such rules. For example, twice of the angle on the Mohr circle corresponding to the angle we rotate here. This is the first one. The second one is why we're rotating on the Mohr circle can really go to replace the formulas for transformation of the stress. And that's the second reason I want to give to you on Monday. And for the third one is we're going to use Mohr circle to the transformation in any orientation. Okay, so that means here we are given tau x y, sigma x, sigma y, and given any angle of the theta, we're going to calculate sigma x prime, sigma y prime, and tau x y prime. And for these problems, we can calculate quickly on the Mohr circle. Okay. Sorry, today we kind of run out of time. Can I just give back to you the test, and then I promise you, I will go over on Monday. Okay. So maybe